Pleasant day to everyone. This is part 2 of Module 4 for the subject CE4111, Highway and Railroad Engineering. We're still going to discuss topics under road safety and traffic accident analysis. So for certain locations along the road, if you are traveling, you would be able to observe that there are some signs indicating that the area is an accident-prone area. There are signages telling us to be cautious. So how do we identify now these locations? So these locations are what we call the block spots or your hazardous locations. And we have different methods in identifying the locations of your block spots. You have generally two. The first one is the statistical method, and the other one is the benchmark method. Under the statistical method, we have the classical statistical method, and the second one is the rate quality control method. While for benchmark method, we have what we call the setting benchmark. Okay, so we'll be discussing these three methods as we progress in our lecture. So for the classical statistical method, this is now a method that assumes the number of accidents at locations of interest or of study, that it follows now in normal probability distribution. So the condition that we follow for classical statistical method is that it should follow this relation, that xi or x sub I is greater than x or the average x plus ks. So if it follows this condition, it means that the location under study is hazardous. Okay, so for this equation or for this condition, xi now is the accident frequency or the accident rate at location I or the location under study. And then we have your bar x or the average x or the mean frequency of all the locations under consideration. K is our constant, which will correspond to a level of confidence from your statistics. S is the sample standard deviation for all locations considered. So generally, in our computations, we'll now consider key values or level of confidence at 90, 95, and 99%, with equivalent key values of 1.282, 1.645, and 2.327 respectively. So if we do not have this, or if this level of confidence is not given, so let's say the level of confidence given is at 93, 97, and others, you could use the table that you have used from your statistics subject, your engineering data analysis. So this is the same values that we will. So this is taken from that table. Okay. So next we have the rate quality control method, which is a variation or simply a variation of the classical statistical method. So in here, instead of following a normal distribution for the accident or the number of accidents at our location, the rate control or rate quality control now will assume that our number of accidents follows a Poisson distribution. So meaning it's a random distribution. So this would simply apply now to rates of accidents instead of frequencies. So in rate quality or QC, we compare now the rate of a particular location to the mean rate at similar locations. Okay, so in the previous method, in the classical statistical method, we consider all of the locations in our study area. So for example, kung sa car region, i-consider ko lahat ng cities and municipalities in car for classic statistical method. While for rate quality control method, my study area is the Cordillera region, pero ang ilalagay ko or i-consider ko lang, ang i-compare ko lang within the car region are those that will have the same characteristics as the area I am studying. So meaning similar characteristics. So for the condition that you will follow for rate quality control method, we have now y sub I should be greater than bar y plus k times the quantity bar y over vi raised to 0.5 plus 1 over 2vi. So if this is now the case of our values, then it means that the location under study is a hazardous area or a hazardous location. So take note for y sub I, that is now the accident rate at location I or at a specific location. Bar y is the mean or the average accident rate for all locations with, remember, similar characteristics of location I. And then we have V is the volume of traffic at the specific location I. And K is the same value or same characteristics as for the classical statistical method, which is a constant value for a specific level of confidence. Okay, so again, when we say similar characteristics, it has the same volume of vehicles entering the, or same ADT, same design. So, parehong kung two-way highway, dapat two-way highway din yung i-consider natin for our study. So, dapat pareho sila ng characteristics ng location ay ninyo. Okay? So, next we have the setting benchmark method. So, this is simpler and it's simply arranging now all accidents with casualties from highest to the lowest value. And from there, we set a benchmark in order to locate the black spots or hazardous locations within the benchmark that we have set. So the setting benchmark method or the simply benchmark method is applicable for countries that have very limited or very small budget with regards to improvement of hazardous location or improvement of road safety. So in the Philippines, kung pwede siyang applicable sa atin kasi hindi naman ganon kalaki yung budget natin with regards to road safety. Okay? So an example of this, so this graph, so if you arrange now your locations in terms of the number of accidents, so highest location here, and then followed by the next locations with lower number of accidents with casualties. So mag-set ka ng benchmark kung gaano karaming number of accidents yung i-consider mo as a hazardous location. And then you see now the intersection ng benchmark sa kanong ating locations. So kung ano yung locations na kasama, so if what are the locations included from this benchmark, so from these intersections until here, so this one now is our places to be considered as hazardous location or black spots. So these are the places that would now require attention or improvement for road safety. So to understand how to locate locations or hazardous locations, let us solve some examples. A highway section has an accident rate of 150 accidents per 100 MVK. If the mean accident rate for all sections is 55 per 100 MVK and the standard deviation is 26 per 100 MVK, should the section under study be flagged as hazardous with 95% confidence? So for our solution, we are going to use now the classical statistical method. So we're given xi at 150 per 100 MVK. And we're also given an average or mean accident rate of 55 per 100 MVK. So we're given a level of confidence of 95, in which the k-value is equivalent to 1.645. We are given standard deviation of 26 per 100 MVK. So before we solve or continue solving, make sure that these values would be the same. So all of the values should be the same na per 100 MVK. Okay? So since all of our values are in terms of per 100 million vehicle per kilometer, then we could apply now our condition or check our condition. If x sub I is greater than x bar plus ks, then we will flag our location or the area under study as hazardous. So xi is 150, x bar is 55, so plus k 1.645 times 26, which will result to 90. So x sub I is greater than x bar plus ks. Therefore, the area under study should be flagged hazardous at a level of confidence of 95%. So if we have a different level of confidence, this value might be different. Okay? So next, we have a section of road has 55 accidents recorded in a span of 3 years. For that same period, the estimated vehicle travel on the section is 23 MVK. Considering only those sections having the same characteristics as the section under study, the mean rate is given at 80 accidents per 100 million vehicles per kilometer. Is the section under study hazardous at a level of confidence of 95%? So for our solution, we identify first our given. So y sub I is the accident rate at the location, which is 55 accidents. So ang rate ang hinahanap, so you have to divide this by the vehicle travel or the volume of vehicles traveling the section. So it will now be 55 divided by 23, which will give us a value of 2.39 accidents per million vehicle kilometer. So next, we have your y bar, which is 80 per 100 MVK, and a level of confidence 95%, which will give us a value of k equal to 1.645. So take note that we are assuming only or considering only those sections having the same characteristics or same roads having the same characteristic as our study area. Therefore, we are going to use here the equation for rate quality control method. So in that case, we follow now the condition y sub I is greater than y bar plus k times y bar over vi raised to 0.5 plus 1 over 2vi. So y sub I, as we have computed, is 2.39 MVK. Y bar is 0.8. Why is it 0.8? Because 2.39 is per MVK, 80 is per 100 MVK. So para maging pareho sila, we divide 80 by 100 para per MVK din siya. Okay? So plus 1.645, y bar is 0.80. The volume is 23. So we compute now. 2.39, is it less than or greater than this equivalent equation? 1.13. So it's greater than y sub I is greater than 1.13. Therefore, the section is flagged as a hazardous location or as a black spot at a level of confidence of 95%. So next, we have, given the following accident rates for a road section, determine the locations that would require attention or should be considered as a black spot or hazardous location. Let's set the benchmark at 230 accidents with casualties. So what we will do is to arrange this graphically by highest to lowest. So highest to lowest, we now have D 350, G 332, B 235, E 225, E is 120, C is 112, F is 98. So if we're going to check now, or graph it, our benchmark is at 230. So at this line, all locations before this line will be our hazardous locations. That will be D, location G, and location B. So next, we have, for our traffic accident analysis, we have to know the cause of traffic accidents. So when there is an accident, aside from having injuries or fatalities, there is also economic losses due to our accidents. And who are those, or who are affected by these economic losses? That would now be the individual who is involved in the accident, the families of those who are involved in the road accident, and also the country or the nation at which the accident occurred. So the losses now from these accidents, the economic losses now, would come from the medical cost, productivity loss, administrative cost, repair cost, and the pain, grief, and suffering cost, in which this cost are what we call the cost components of traffic accidents. So for medical costs, this would be the cost of treating injured persons from the collision and will include the doctor's fees for surgeries, for consultations, the medicine for recovery, the time spent in the hospital, and the long-term care associated for the care of individuals who are severely and are permanently disabled. Next, we have the pain, grief, and suffering, which is an allowance for the loss of quality of life, pain, grief, and suffering that is incurred by the injured himself and their families and friends. And since pain cannot be assessed in terms of money, this one now is taken as true intangibles. Therefore, there is now an assumed lump sum or proportion to the accident cost to follow the emotional loss. So for the next one, we have productivity loss, which is the largest resource cost incurred by traffic accidents or any kind of accident, which is measured as the loss due to loss of productive manpower. So the productivity loss is also known as the lost output, wherein value of work that an injured person would have produced during the time they were absent from work. So for example, certain person E was involved in an accident and he has to recover for 3 days. In that 3 days, the company and himself has lost a 3 days worth of money or of work. So that is now included into what we call productivity loss. Next, we have vehicle repair, which is also known as property damage, is the cost of repairing vehicle and other property damage. So this would include costs paid by the person and by the insurance company. So aside from property damage or vehicle repair, so the vehicle, let's say, collided with a street lamp or with a wall of a certain establishment. So aside from the repair cost of the vehicle, you also have to include here the cost of repairing the lamp post, the street lamp, or the any property that has been damaged due to the accident. So next we have the administrative cost, which is the cost incurred by the police and other service in the process of attending crashes and associated activities. This could also include the cost to administer insurance claims. Aside from this could also include legal services, which is taken as a percentage of the total resource cost. So when we say total resource cost, that is simply the sum of the cost of medical, the pain, the loss output, and the property damage. Okay? So administrative cost, example, magkano yung nagastos for legal actions, legal mga demanda, that is administrative cost. Okay? So next, the cost of traffic accidents based from EDB 2012 and which wrote the Transport Sector Assessment Strategy and Roadmap of the Philippines. As of 2005, the national cost of road accidents in the Philippines is 2.8% of the country's GDP. If you recall, from the study of WHO or the report of WHO in 2018, it has already increased to 3%. So in 2008, the road accidents became the fourth leading cause of death. And with this, it has contributed to the loss or the cost of the country in terms of traffic or in terms of accidents. So, in a study by an non-government organization, the Imagine Law, they were able to identify that road crashes would at least cost 105.7 billion pesos every year. And that in this total cost of road crashes, 5.7 billion of which is located or is given to medical treatment. And 100 billion are given to opportunity losses. So in the same study, they were able to identify that for a value of 3 additional causes would include 3.5 million pesos would go to property damage costs, funeral costs, medical costs, and labor output costs. And an additional 506,000 would go to pain, grief, and suffering, and 76,000 additional costs will go to vehicle repairs. So for each cost component that we have identified and for each severity type of an accident will be a certain correlation. So when we have a fatal accident, it will now include lost output, pain, grief, and suffering, medical costs, administrative, and vehicle repair. For serious injuries, this would now incur lost output costs, pain, grief, and suffering, medical, administrative, and vehicle repair. While for minor injuries, we have the lost output, medical, administrative, and vehicle repair. So sa minor, siguro, one day lang naman yung pagka-recover, hindi mo iiyakan yung sugat na yon. Kaya hindi kasama yung sa minor injury yung pain, grief, and suffering cost. And then, for damage-only type of accidents, the cost component now will be administrative and vehicle repair. Since sasakyan lang ang na-damage, sasakyan lang nasira, walang nasaktan, walang namatay, so hindi kailangang mag-absent para magkaroon ng loss doon sa productivity ninyo. Tapos, hindi din magkakaroon ng pain and grief yung family sa kayong tao with regards to the loss of the loved one. And wala namang magkakaroon ng walang nasaktan, so no need for medical cost. In estimating cost accidents, we have different methodologies. We have the gross output or the human capital method, the life insurance method, court award method, the implicit public sector valuation, net output method, and the value risk change or willingness to pay method. For life insurance method, this measures now the valuation of the risk associated with the road usage. Next, we have the court award method, which is based on actual compensation settlement that is awarded between those involved in accidents. So this is influenced by the degree of negligence found during the accident. And then we have the implicit public sector valuation method, which sets implied values or expected values used to value human lives. Though we have several methods in estimating the cost of accidents, in today's time, there are only two main methods used to estimate the cost of accidents. That is now the gross output or the human capital method and the value risk change or the willingness to pay method. For gross output or the human capital, this focuses on the economic consequences of the road accident. This usually includes an estimated sum that would reflect the pain, grief, and suffering incurred by persons and family involved. And this is based on the idea that the value to society of avoiding death or injury is related to potentially lost economic output resources. So the gross output or human capital method is most recommended by the Asian Development Bank for developing countries, while willingness to pay method is more preferred as a costing method for developed countries. This is the best way to measure costing of accidents for benefit cost analysis. So for cost component estimation, using gross output, the productivity loss is computed in terms of injuries is simply the sum of the average daily wage rate of each person involved multiplied to the number of days of work. So let's say the average daily wage of person A is $350 per day, and then the average wage of person B involved in the accident is 300. So take up the sum of their average daily wage and then multiply it to the number of days they have to be absent because of the accident. That will be your gross or your productivity loss cost or the loss output cost. In terms of fatalities and permanent disabilities, the productivity loss now is computed over the rest of the expected working life and discounted to an equivalent present value. So, let's say, yung namatay o kaya yung na permanent disability na tao is, let's say, 30 years old. Tapos, ang retiring age natin sa Philippines is 65. So, meaning, you have to cover your calculations or computations in a time of 65 minus 30. So, ibig sabihin, in your computations, that will now be 35 years. So, you have to cover the productivity loss of that person within 35 years. And then, equate it to an equivalent present value. So, next, we have for pain, grief, and suffering, percentage. This is computed as a percentage of the lost output or the productivity loss cost. And ADB recommendation is that for pain, grief, and suffering for fatal accidents should be 20% of the total lost income. And for serious injury, it will be 50% total lost income. And for minor injuries, it is 30% of the total lost income. Then we have vehicle damage or property damage is the average cost of the vehicle repair, which is sourced from insurance company records, multiplied by the average number of vehicles involved in the crash. Then for medical costs, for long term, this will now be computed as the annual cost of care for persons permanently and severely disabled, and will be performed over the rest of the expected lifespan and discounted to an equivalent present value. And then we also have your short-term medical cost, in which it's computed as the sum of the average health of hospital stay for each injured multiplied by the average daily cost of hospital care. And lastly, we have your administrative cost, which is a percentage of the resource deaths. And ADB recommends that for fatal accidents, the administrative cost will be 0.2% of the total resource cost. And then for serious injuries will be 4%, minor injuries is 14%, and for property damage only accidents, it will be 10% of the resource cost. Okay, so that's it for locating hazardous locations and for traffic accident costs. So thank you for listening.